everyone. This is Revati working as an assistant professor in the Department of Information Technology from SNS College of Engineering, SNS Institutions, Coimbatore. In my today lecture series, we are going to see about unicast routing, which is example for the path vector routing. Before you are moving on to the topic, you have to know about the routing. Routing is the process of selecting best path from the source to destination in order to transfer the data transmission. Here the path vector routing is based on the least cost goal. Least cost routing does not prevent a packet from passing through your network. Then in least cost routing protocol applied in both link state routing and also the distance vector routing, and does not allow a center to apply specific policies to the packet, and it does not have any drawbacks of link state and the distance vector routing described in the least cost routing. And also the source will control the path in through the which path the data will be transferred in the efficient manner. Here the concept of spanning trees are used. The path from a source to all destination is also determined by the best spanning tree. The best spanning tree, however, it is not a least cost tree. It is tree determined by the source when it improves its own policy, and the source will select the path from source to destination through the which path it can transmit the data in a network. And also it creates a path vector based on the information it can obtain about its neighbors. It will also immediate data transmission to its neighbors in order to collect the data, and also uh, it will collect the piece of information from the source. Then path vector is a routing algorithm in unicast routing protocol of network layer, and it is useful for interdomain routing. The principle of path vector routing is similar to the distance vector routing. It assumes that there is one node in each autonomous system that acts on behalf of the entire autonomous system is called speaker node. The speaker node is act as a source node of entire network. A speaker node advises the path, not the matrices of the nodes in it autonomous system or other autonomous system. The autonomous system is nothing but data transmission within the network, within one network. And one autonomous to another means within between two types of networks. Either it can be a LAN, WAN, or PAN. Here is the example for path vector routing. Here each node, after the creation of the initial path vector, it to all its immediate neighbors. Here the each node, when it receives a path vector from a neighbor, its path using an equation similar to the Bellman-Ford algorithm. Bellman-Ford algorithm is nothing but selecting a least cost path from its neighbors. Here the least cost node will not be selected. Instead of that, the immediate neighbor will be selected as the source node. The main concept of this path vector routing is in each node will maintain your routing table. Here the given example, there are 5 nodes are available. Here the nodes will be a device or a hardware device or a network device or a system. Here the A is one of the system, and its immediate neighbor is B, and B is the one of the system available in the network, and C, D are the immediate neighbors of B, and C immediate neighbors are B, D, and E, and D immediate neighbors are B, C, and E. Here, the each and every node in the system will maintain a routing table in order to find the best path between the source and destination. Here, the A is act as a source. How to find the distance from A to each and every nodes present in the network. Here, the routing table will contain source node and immediate neighbors node. Here for A routing table, from A to A, only A node will available. Then A to B means A comma B. Then there is no direct path between A to C. It can reach the C node through the B node only. So that distance is infinitive now, and D also like that, and E is also having the unknown distance, because there is no direct path between A to E. Likewise, the B routing table will contain A, B, C, D, and E nodes. Here, the B is the source node. How to find the immediate neighbors of B? Here, A, C, and D are the immediate neighbors. So it can be denoted in the routing table, like B is the source node and A is the destination node, and B is the source and destination, and B is the source node and C is the immediate neighbor node, and B is the source node and D is the immediate neighbor node. There is no direct path between the B and E system, so it can be denoted as unknown distance. Then how to calculate a routing table in the C node, and there is no immediate and direct path from C to A, so it is denoted as unknown column, and from the C node the immediate neighbors are B, C, D, and E. It will be denoted in table, and D routing table will be there is no direct link between D and A. It can be denoted as unknown distance. Then from the D node, there are three immediate neighbors are there, B, C, and E. It will be denoted in the routing table, like D is the source node and B is the destination node. D is the source node and C is the destination node, and there is no self loop between D and D. It will be directly denoted as D, and D is the source node, E is the destination node. Likewise, how to calculate routing table for the E node. There is no direct link between E to A. It is denoted as unknown distance, and there is no distance direct distance from E to B. It will be denoted as unknown distance. The E node immediate neighbors are C and D. It is denoted in the table as known distances. Likewise, how to calculate the unknown distance from its initial routing table. The by the conclusion, the path vector routing is used to calculate path from A to from each and every node to other nodes available in the network, and it is not based on the least cost like distance vector routing and link state routing. Thank you for watching. Thank you.